Hello students, welcome back. This question is also from GATE 2007 exam. It's for 2 marks. First of all, let us read the question. So you can see in these first two paragraphs, they're only mentioning the information that you already know. So you can just pause the video and read it yourself. The actual question begins from third paragraph. It reads, consider a two-level logic implementation of the look-ahead carry generator. Assume that PI and GI are available for the carry generator circuit and that the and OR gates can have any number of inputs. The number of AND gates and OR gates needed to implement the look-ahead carry generator for a 4-bit adder with S3, S2, S1, S0 and C4 as outputs are respectively. Okay, so we need to determine how many AND gates and OR gates are required for implementing a carry look ahead generator. Keep in mind, we want only generator, not the complete carry look ahead adder. Okay. Also, it's given that fan in can be anything. We can use a 4-input OR gate also. Okay. Similarly, 4-input AND gate is also given. Now, what is a carry look ahead generator first of all? See, we can use a normal adder for adding two n-bit numbers, or we can use a carry look ahead adder. In normal adder, you will add these 3 bits, get the sum S0 and the carry C1. Then you will add these 3 bits and get the carry C2 as well as sum S1. Okay, so it will go step by step. If it is a n-bit number, for example, here we have a 4-bit number. We want to add A and B. Okay, for adding 4-bit number, there are 4 stages. Okay, similarly, if it is a 20-bit number, there will be 20 stages. That means total time taken will be dependent on number of stages. We just want that this addition happens in constant time irrespective of number of bits. That's the reason we use a carry look ahead adder. Okay. How does a carry look ahead adder works? It works in 2 steps. In step 1, all of these carries C1, C2, C3, C4, they are generated. Okay. In step 2, we just perform addition in constant time. That means overall time taken is constant. See, we can generate C1, C2, C3, C4 in constant time without actually performing these additions. Okay, I hope you know that. If you don't know about this thing, you can watch my theory lectures on this topic. Anyways, you can analyze these formulas for deriving or proving that this can be just performed in constant time. Okay. Now, step 1 takes constant amount of time. After completing step 1, you will have all of these carries as well as both of the input numbers. Okay. Then these 3 can be added, these 3 can be added, and all of these additions or all of these stages can occur in parallel. Now the question is, we want to generate all these carries. Okay. They're asking how many gates will be required to implement a carry look ahead generator. Okay. We just want to implement first step. That is, we just want to generate the carries. These are the carries that need to be generated and their formulas are written here. You can see we need value of C0 as well as all the GIs and PIs. Okay, that is carry generates and carry propagates for calculating C1, C2, C3, C4. Okay. Now, they are saying GIs and PIs are already available to us. Okay. That means we know the value of G3, G2, G1, P3, P2, P1 and so on. We just need to calculate these 4. How many AND and OR gates will be required? Let's see. For implementing a circuit for C1, you will require only one OR gate because you want to perform OR of this term and this term. So one OR gate is required. For C2 also one OR gate will be required. See, you need to perform OR of this term and this term. Okay. You can use a 3-input OR gate. So one OR gate is used here. Similarly, each of these will use a OR gate. So in total 4 OR gates are used. Okay. So option A and option D can be rejected. Now let us see how many AND gates will be used. We need to calculate AND of C0, P0. One gate is used here. then one gate is used here, one gate is used here, one gate is used here. Okay, then one gate will be used here. 5, 6, 7, 8, 9, 10. Okay, 10 gates are used. That means answer is B part, 10 AND gates and 4 OR gates. Okay, now you can see I took like around 10 minutes just to explain you this topic. Okay, if you already know the basic stuff, this question would just take like 50 seconds or 1 minute or maximum 1.5 minutes, because you just need to write down these equations and count the number of gates. Okay, so don't panic if the statement of question is very lengthy. Anyways, let me show you C3. How is C3 implemented? C3 will use one OR gate. That will be 1, 2, 3, 4. It's a 4 input OR gate. Okay, and it will use 3 AND gates. Okay, so I've just drawn the circuit for C3 here. Okay, it uses one OR gate and 3 AND gates. Similarly, you can just see how all of these 4 will be implemented, and total of 10 AND gates and 4 OR gates are required. Your answer is option B. Okay. Okay, one more thing that probably I skipped while making this video was, in offline classes, one student asked me this doubt, that why is answer not A part? He claimed that answer could be option A because we need not generate C4. See, when we have generated C1, C2 and C3, step 1 is done. We can directly add all of these. Okay, so we will add all of these 3 and full ladder will generate the sum as well as the carry out. Okay, so he said that we can skip generating C4 because this is not required in the next stage. Okay, so only these 3 have to be implemented. That means 3 OR gates, so 3, and 6 AND gates, so 6. That means answer must be 6, 3. But there is a small mistake in this. Can you think what it is? So I'm going to tell you. You just pause the video and think it yourself. Anyways, the answer is, he thought that we are going to use a full ladder here. No, it's not the case. In standard carry look ahead adder, we already have this XOR of these two terms. That means PI. So we just XOR PI with C3 to get the sum. Okay, this is the formula. Probably it was mentioned in the question. I don't actually remember. But we use this formula to generate sum. Okay, that means only S3 is generated. We will get S3 upon performing this addition, but we won't get the carry out. Okay, we won't know what is C4. So C4 has to be generated by this step only. Okay, we actually need to implement the circuit for C4 also. That means our answer cannot be option A. Answer can only be option B, that is 10, 4.